Hi, welcome to Main and 5W channel for yet another, I think, the most interesting topic about human senses and software development. We all know like this has been a topic for last 30, 40 years, maybe 3, 4 decades. We could see that computers have been able to really explore the touch, explore the visual interface, which is UI, as well as the sound very well, but not much on the touch, smell, and taste when they started off. But as the day went, we are trying to really look at like solutions which could use all the five senses. And later we had a concept like artificial intelligence, and we talked about robotics, where you could actually simulate your human brain and try to really program your senses. Okay, so human senses and software development is a topic. So let's see my point of view. There are a lot of things available on the internet and Google, but this is some of my point of view. First, let's summarize some of the perspectives, some preambles for people to really think through what has happened in the last 10 years for you to get a feel of human senses development and programming. Number one, there was census development, which was typically academic in nature. You go to Stanford, you go to basically Harvard University, you could go into the research institutes in the specific countries. The census development was seen as something very really core niche area where people could really detect a smell, people could really detect a touch and do a lot more innovative solution. So the census development has moved from those research into a concept like artificial intelligence, machine learning, and deep learning, specifically deep learning, where you're trying to do some heuristic kind of development, you're trying to do a neural network management where you're mimicking the brain. Okay, so AI branch, which we call deep learning, is trying to really help the census development very much, because today we have APIs, today we have a kind of IDE, today we have the frameworks, everything available for people to really develop. In the past, it used to be very raw. People have to write large amount of codes to really process. I remember writing something in C++ or a language like C, where you have to write a lot of low-level stuff to really develop any codes on the census side. So first point of view is census development has matured from a very core raw programming into something which is driven by the modern emerging technology with a lot more support from the tools. When I tell a lot more, there's still a lot more to come, because today you don't have an IDE for census development by which you can pick and choose something. So that's still 5 years, 10 years from now. Okay. The second is OEM solution to support this. Basically, what has happened in the last 5-6 years is you had this concept of cloud, which came in. Every vendor, like with Amazon Web Service, the Google Cloud Platform, Azure, all these people have created infrastructure and platform by which you could really make use of those processing power, which is pay per use, which is basically very infinite, for you to really process those huge amount of data which will come in while you interact in these kind of development. So if you go into multiple vendors, maybe you go into the Microsoft research site, you go to Amazon research, you go to Google research, you will find there are a lot of interesting projects around the census development, but they will be using core solutions from the OEM to really develop those tools. The third aspect of perspective is the customer experience. So what you're trying to end doing by doing all this is basically trying to get better customer experience, right? So if you really see the Alexa of the world or the Google Home of the world, what you're trying to do is you're interacting with a voice. Okay, so you're talking to it and then it's able to really call a syntax or a semantics or a grammar at the back end and then try to get you and fetch you information onto your voice. So there is a voice interaction. So that's quite famous, because the customer experience of somebody who's been using and typing through his user interface, which is actually seeing and typing physically, is moving into talking, which is, so that is where I think the real change is coming in from a perspective. Similarly, if you really see, there are programming now for touch sensors. So everywhere you go for a security, there are a lot of ways by which your fingerprinting, your retina scanning, all these are taking over. So Customer experience is very important in this particular area. So for example, if you really want to smell something and detect something like a smoke detector, the branch of Internet of Things is really working on all these senses development, where you have a sensor, you have a kit like Raspberry Pi or Arduino which can get embedded, and then it can detect these kind of experiences, and then you can process what to do, how to do, and you can also prevent these kind of things. So all said and done, it's a basic customer experience, right? So if you take from an industry point of view, if you're working in a telecom company and somebody is in an ATM, somebody is in the customer experience to pay his bill, blah, blah, blah. And he can just, when he's walking in, a camera can scan and really get the vision part of it and then see what the person is doing. And you can also detect his face. You can do facial detection in terms of whether he's happy, smile, and then you can give a feedback why you're not very happy with the service. So you can do something very interesting to improve the customer experience, right? You would have heard about robotic banks, robotic restaurants, robotic surgery, blah, blah, blah. So the customer experience is changing because what a human can do, whether the systems can think, whether systems can really smell, systems can really touch, that's going to be a very interesting area. The fourth area which you will see this very related to is automation, autonomous, robotics. So robotics is one area where it will go on end, but you can see that the machines are going to co-work with human beings. So, and machines can start using all these sensors, and that's when there will be a lot of competition between man and the machine, right? And then where you will end up here is basically a human can be better emotionally, good in relationship, social stuff. So that's where they'll dominate on the machine, where the machines are very strong and running a logic without any fatigueness, blah, blah, blah. Okay. The last point is the integrated view of senses, because we could see fragmented. So if you search in Google, you get a million results and you will keep going and searching here, and there's no integrated view of senses. So what I mean by integrated view of senses, suppose you're a Python developer who are trying to use the infrastructure of Amazon Web Service, you will find some tools coming here and there, left and right, but you don't find one IDE where you can really develop this together. So it's going to be very fragmented. So you could see that over a period of time, there are more integrated view of sensors where the DL and ML and AI is becoming a friend. And like already we are talking AI first kind of applications, but basically it's still not there. Okay, it's a very early stage is what I could call. So that's a preamble. So anything which is there today in computing started with science. So when you want to mimic the science, you need to understand the science. So I'm not here going to teach you the vision or anything on the reflectory or ears or basically your touch or your facial recognition, but I just want to run you a few things before we really look at some of the products which are there in the market by which you can really start developing. Okay, so if you see the structure of the tongue, the idea of knowing this is I have seen people who have been working on trying to do some research projects, or you could see some people who are trying to use how do I really feel the taste. Okay, if you want to really mimic the taste of human beings, so can a robot taste something? Is it possible that you have an equipment which can really take whatever is coming in the supply chain, maybe a biscuit or something like a kind of a toast which is coming and can taste and then tell this is good, like a human being, right? So for doing that, one side is basically your development, blah, 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 but the other side is to know the structure of the tongue. You can see how complicated it if you are to mimic such kind of experience, because human tongue has three distinct divisions, which is apex, the body, and you can really see it's got so many parts like the dorsum of tongue, fungiform papillae and facillate papillae, and that's palatine tonsils. So if you really want to do a research on this area, you are actually mimicking this, and then only so what you do naturally is you pick something and put it on your mouth, and then the tongue tells you like this is sore, this is, so you have to mimic that, right? So for that you need to know what is the structure of the tongue and how it works. Similar to that, there's the taste bud. Taste bud tells sour, it tells salty, it tells bitter. So it's a muscular organ in the mouth. It's covered with moist pink tissue called mucosa. Tiny bumps called papillae give the tongue its rough texture. Thousands of taste buds cover the surface of the papillae. Taste buds are a collection of nerve-like cells that connect to nerves running into the brain. Very interesting area, because if you really want to get here, you end up your 30, 40 years or 4 decades into this particular area, because there are so many things you can really research. So you can write a development program where you're trying to feed something into the system and the system tells it's bitter. So there are already a lot of programs like that, but you can really develop this and then start thinking of an utility, then start thinking in which industry you can put it, blah, blah, blah. Okay. So this is the smell, because, like smelling is another sense, like you can see the dogs can smell far better and human beings can smell. So how do you really automate these things? How do you create autonomous system which can really detect this, right? So macrosomatic, the sense of smell, well developed to give warning of environment. Microsomatics in human is less developed. So basically you can see that even with humans, even with animals, even with certain specific birds, you can really see that it changes. So, but what you need to look at is the art of smell. What is smell? How it works? What's the science behind it? How do you automate it? That's going to be a very interesting area to really look at. So you can see practical applications in a factory where there's a fire, there is a kind of a cloud smell, there is something like that, something coming in, and then you can detect it and take some actions. So today, how do you measure the sense of smell? You do qualitative tests. So this is why I'm putting this, is basically you will reverse engineer this concept, because if you can actually measure the sense of smell, it means like there is some formulas, some rules which people have already created. You can actually automate those rules and then start putting these kind of logic into a systems or something different which can really help you. So what is the measurement of sense of smell? Like you can do qualitative testing by asking patient to smell common odors with eyes closed. You can do olfactometry with quantitative estimation of smell with olfactometer. So this is various ways to really look at the smell part of it. And then we look at facial recognition. So if you really see, I'm not talking about visual because there are so many things happening on the visual side, which is your user interface, the sound part, which is pretty easy with your ears. You can really hear, and how the ear works, how your eyes works are pretty quite common. But what people don't think in a computing paradigm is how do you taste, okay? And how do you really look at it from a perspective of the smell part? Because these are difficult senses to automate. The other part of it is facial recognition. This is an image form, this is a capture form. Is a form of computer vision that uses faces to attempt to identify a person. So the facial recognition is basically, you can see that there are different principles which are used. I'm not getting into the formulas, but the idea to show you this is you can mimic this formula to really look at coordinates of a face and is real emotions, and see for this is how it looks like. There are various type of emotions by which you can really detect face. So after your senses, which is UI, which is see, which is hear, smell, taste, okay, and then the touch part. Basically, you have the facial recognition, which is also part of an imaging technology. And then people talk about sixth sense. The reason why you need to see this all together is basically they're all technologies which are closer to each other. So for example, if you are interacting with the customer whom you have to develop something for retail customer, right? So you have to have a broad knowledge of sense development, right? Sense programming. You should know what are the tools available, what does the cloud provider provide, what are the frameworks available, for what do you need to really customize and write your own code, blah blah blah. Okay, so for that, knowing all these things really helps. So sixth sense is a wearable gestural interface. So gesture interface is also very important today. Like we talk about augmented reality, virtual reality, mixed reality. This is something which is very commonly used word today, right? So sixth sense is another word. So I think you missed AR, VR, MR. You can also add that to this list because they also will help you in better customer experience. But drastically, they're not related to human emotions, but generally they can be really mimicked with these kind of technologies. So what is sixth sense? Is a wearable gestural interface that augments the physical world around us with digital information. Let us use natural hand just to interact. So it's fantastic, right? Because anything which is natural. So we know the 3 A's: automation, autonomous, and then you have augmentation, right? So when you talk about augmentation world, basically what you're trying to talk about is you have physical object, you interact, you go to a car, you go to a bike, and you start interacting with your natural experience on these objects, and then you start getting some results. So that's what nothing but Sixth Sense is about. What Sixth Sense? A technology based on the concept of augmented reality. It's an integration of the real world object with the digital world. It's an extrasensory perception. That's the name. So actually it was proposed by Steve Mann, developed by MIT Labs, and then in 1998, then you could see that Pranav Mistry, you can see his videos, pretty interesting videos. He created a wristband that could read a radio frequency identification tag. Then there was a larger projector that was mounted on a helmet. So, see, practical way of thinking this is like maybe a layman might really see this is pretty expensive, not very natural. And it looks very good in the labs, but as the day goes, maybe 10 years, 15 years from now, they will be available like a mobile phone. Okay, so wearable is already available today. We use smartwatch, we use Fitbits, but you could see like these devices will develop across the global, and then they become more cheaper, then they become more consumable, and then people start using it like they use a mobile phone. Okay, so the history will repeat itself. Like every time something new comes, they are more seen in the labs, then they're seen more on the OEM research projects, then they're seen on the core products, then you find some solutions, and then it becomes very common with all the human beings. So B2B with and B2C is going to really happen here. So this is how the Sixth Sense happens. You have a camera, microphone, projector, mirror, color makers, mobile. So I would recommend that you see videos of Pranav Mistry. I think it'll be very interesting for you to really get it. So what happens here is a camera is an object in view, tracks the user's hand gestures. It sends the data to the smartphone. It acts as a digital eye, connecting you to the world to a digital. And the projector, what it does is graphical UI of the selected into surfaces or walls in the front. It contains a rechargeable battery. The mobile computing device provides the content to be, and there is a mirror. Usage the mirror is significant as the projector dangles pointing downwards from the neck. So users can manually change the tilt of the mirror to change the location of thing. And then finally there is a smartphone. It's a web-enabled smartphone. User's pocket processes the video data. Okay. So what is very interesting here is like there is also an API which Pranav talks about somewhere, like where you can actually use those API to write something very custom based. Okay. So this is how it can be used. You can make a call with your hand. You can use your hand to make a call, and you can actually click pictures with your hand instead of having a physical camera. You can use augmented newspaper. You can play games on any surface. Okay, you can print on basically with your hand. So all this is possible by using. So see, what is very key for you is to look at how does the user experience change because of this. Today, if you go and ask even a kid about Alexas of the world, Google, they're quite comfortable. They play music, they play whatever they want. The encyclopedia is via the voice. Right, so that's because if you talk 5 years from now backwards, people could not have dreamt about these kind of technologies which is available household. Okay, and that's where the importance of it. So just a quick summary about what I wanted to speak here in this session is, when I talk about senses development, I'm talking about how this is a very key part of your entire project solution. So in your project solutions, maybe you are developing for a customer, you're in a migration project, you're doing modernization project, you're re-architecting the project. Basically, there is customer experience you can improve with these kind of technologies. So AI ML is always there in most of the projects today. By using IoT, deep learning, trying to really look at the senses part of it to see where is it relevant for the end customers, right? So it can even be used for accessibility. So you look at the market where it can really help people who are really physically challenged kind of thing. So there is huge amount of scope for this. I could call it less than 10% really being valued as the potential, because people still have to find the use case and implement the use case. There are a lot of planning, research available from an implementation perspective. If you go to your nearest hospital, you go to nearest airport, you will see very less of them. Okay, when you really Google from a research labs, you will find plenty of them. Okay, so let's see some solutions what I wanted to really show, as usual, I want you to really go to the Wikipedia of sense, have spent at least a day to understand about the how from the signal to collection to transduction to processing to action happens. Like you need to understand the brain function because that's a signal processing unit for you, right? Anything which you see, it has to be through the brain signal. So you should really look at going through this entire Wikipedia to really get. So this is not our session. So it talks about the sensory modalities, receptors, thresholds, signal detection, sensory adaptation, okay, Fourier analysis, right, and then human sensation, okay, from a visual system, from auditory system, from somatosensory system, which is touch, gustatory system, which is taste, and then the olfactory system, which is the smell, okay. Just have a look at all these things and then really understand what this means for from a biological perspective, which can really help. Now, when it comes to from an IT perspective, I just thought some of the articles quite interesting on what IBM talks about. So if you really see, IBM has got a research lab, and then so they're talking something. So I just picked up few for no order in terms of this is the best or this is second. Just sharing some information from the OEM. So what IBM talking, human senses in computer, the next big thing is what IBM talks about. And IBM unveiled the 7th IBM 5 in 2012. And after that, this article was released around 2017. It talks about like touch sense, touch sight, hearing, taste and smell. The next big thing is about that. Okay. And then they talk about the various approaches by which you can really develop hearing, which we all know, taste, okay, how it can be really utilized. For example, it talks about many communities in sub-Saharan Africa only have access to few base English for any given meal. A creative computer can optimize flavor profile with this constraint, creating a variety of never thought of meal that please the palate. So this is possible. Similarly, you have smell. You can also look at a project from Azure Florence. There are a lot of projects available from every vendor, but you can really search this on Florence, which is a vision and language thing. It talks about human perceive the world through many channels, such as images viewed by the eyes or voices heard by the ears. And you can really see it's a vision language learning. Okay, Azure Florence is founded by Microsoft AI Cognitive. Now let me first define cognitive. Anything which is relevant to sensors, anything relevant to AI, those services will be. So every OEM, every when I tell like product companies like Microsoft, Oracle, IBM, and then Google. Similarly, the services companies around the world, maybe HP, maybe Infosys, TCS, the consulting companies, Accenture, Cap, all of them will be really looking at how to really create a cognitive practice. So there will be a cognitive practice anyway existing today everywhere. But they're still maybe working on the very 50, maybe 5% of their capability, because there are so many things they can do in the next 20 to 30 years to come. So here they were talking about Azure Florence VL is funded by Microsoft AI Cognitive Service Team. The project has been funded since 2020, motivated by strong demand from real application, recent research progress on computer vision, natural language processing and machine language understanding. We strive to advance the state of the art, develop the best computer vision technologies. You can see computer vision being spoken about as a big papers in BTechs, the engineering and also the master degrees, and then also in the doctorates. You can refer those interesting projects done by the fellow people. And there is something called multimodal pre-training. Recently, vision and language pre-training has shown some great progress toward addressing this problem. And then you can see novel image captioning, video understanding. Okay, now you can actually, so far we've been focusing on images, a lot of videos, live cameras, and many applications in our account video understanding. So you can actually debug. Now you can see when you 90% of the people today start their entire life with opening a YouTube channel, right? And then the videos are being seen. Now, what if you can really analyze this video for what is the content? So you can already, YouTube is running a lot of algorithm for what people are searching, what is the relevant ranking. Similarly, what content is going inside the YouTube can be searched, okay? and you can actually look at video, text, data to learn image, motion features, blah blah blah. Okay, and you can use this now practically beyond entertainment, beyond a kind of a YouTube platform, to something very practical in nature, right? For training purpose, maybe for guidance purpose, to help the accessibility team, blah blah blah. You can also see there's one more article which I was reading, which typically talk about mysteries of the senses. Okay, there is so the reason why these are very interesting is because if you really see how these products are really getting created. Now let's log in into the Amazon console to the end to really understand, do they have anything to the topic what we are talking, basically. No, now in a practical scenario, what you will do is you will either have something like a programming language background, and when you start working on to code for it, or you might really use one of the tools like what I'm using to really jump into the console and then see whether you can actually develop. So this is the Amazon's web console. You can see that straightforward there is compute. Now compute is not, it's very important, because when you are doing something like a natural language processing, vision programming, census development, deep learning, you need huge amount of power. Okay, the compute is provided by the cloud, so it really helps you, right? So you can see a lot of compute stuff, a lot of container stuff, storage stuffs, database, we don't touch that. And you can see that certain migrations, developer tools, custom enabled. So you can see something called robotics is here, which is very interesting for our topic today. Something called satellite, okay, something for quantum technologies like Amazon Bracket is very interesting. And you can see that there are things for media services. Okay, machine learning has got a lot of areas by which what we are talking today. Okay, how to do detection of text, detection of video, handwriting, blah blah blah. Okay, and there's a lot of analytical thing areas for it. And then even for security, you can see Amazon Mackie is a deep learning security module by which you can identify predictively a lot of things. Okay, and then there is AR and VR by using the Amazon Sumerian, and you can see that IoT is also a very key area where you can really develop senses. You can actually detect what is a smell which is coming in through a smell sensor or something which you were planting it into the real object. Okay, so that's a very brief about today's session. Hope you found it useful. So the idea of this entire session was to really get an integrated view, because there are a lot of students who might get lost in terms of, like, they're quite interested to get excited to do this kind of projects, but really see the reality. So what you should do is to pick up a use case which is beneficial, which has got a real value to the end user, and then you might want to really mix and match. So thanks for watching. We'll meet for yet another very interesting session.